So hello, welcome to video 6. This is about adding expressions. Let's just go ahead and jump in. Today we talked about adding 2 expressions in our journals. This was our first warm-up problem, and we're just looking at how to add the expressions negative d plus 20 to d plus 20. So there's a few steps that we do when we're adding expressions. The first is we're going to go ahead and write it as an addition. So we have our first quantity on the left and added to the second quantity. This is really key. We're going to regroup the like terms. So this is a combination of the commutative property, which is moving terms around, and the associative property, which is putting them into groups using parentheses. So we have our 2 terms with d in them. Negative d plus d is now a group, and 20 plus 20 is now a group. The variable terms first, and then the constant terms. So then we add each set. So we talked about in class today that first set, negative d and positive d are opposites, and they make 0. They could be written as 0 times d. They actually make truly 0 because they are opposite in value. The 20 plus 20 is easy. That makes 40 as a constant term. So there would be an additional step here, which is just to rewrite. Since 0 times d, the first set of variable terms is 0. That would be added to 40, and so the final expression is 40. This is what we went over in our journal today, an example involving opposites. So next slide. We did some basic algebra practice today in class. This is going to be some more context examples. We see a picture of Delilah. She's going to sign up for these 2 different clubs. One is a Rock Climbers Club, and we see it says a $65 initial fee, and it has a $40 monthly fee. So that's in this first kind of poster. So second poster, right? She's going to the health club, and looks like an initial fee of $80 plus a monthly fee of $50. So we want to write an expression for total cost, how much she's going to spend after a certain number of months, which is m. That's our variable. So what's most important is writing these expressions. A lot of times we have this kind of idea of a fixed or upfront fee or charge, and then one that's variable, that's over time. So in the rock climbing, the $65 happens once. That's our constant term. It doesn't have a variable next to it. But the 40m, that has an m next to it because it's per month, right? So $40 per month, that's written as 40 times m. So 65 plus 40 times m, a fixed charge of $65 and then $40 per month. Health club, very similar. We've got that initial charge, $80 per month, sorry, $80 upfront, and then $50 per month. So they come in these 2 sets. One that's fixed, constant term, one that's variable per month. Adding them together is what we want to do next. So we're writing this as a sum. We just have the rock climbing on the left, the health club on the right. We want to rewrite those. So the upfront charges, $65 and $80, those become a group. We're going to add those 2. And then the monthly charges, $40 a month and $50 a month. Add those together. Makes sense, right? Because they're like ideas, like terms. Go ahead and add these 2 together. $65 and $80 gives her an upfront charge of $145, and then $90 per month coming from the 40m plus the 50m. So this is a context example. Again, a lot of problems have this idea of a fixed initial value, in this case the initial fee, and then a variable value that changes per month or per week or for a certain amount of time. Very similar example. Sorry, I kind of left this picture in. Let's get rid of this picture. Forget the picture. Okay, my apologies. This is not about the picture anymore. But let's go ahead and do this example. So similar idea, I'd like to actually give you a couple of minutes to think about it. Megan and Tamara open a joint account together. They each make an initial deposit of $250. Tamara deposits $150 per week, and Megan deposits $175 per week. What is the amount in the account after W weeks? So think about this for a second. How is this similar to the last example? What would the initial kind of ideas be? What would the weekly ideas be? And how could we write each of those for each of these two people? So Megan, right, she's making this initial deposit of $250. So that's just a one-time deposit. Doesn't have a variable next to it. It's a constant term. But she's depositing $175 per week. So that gets a W next to it. 175 times 1 week, or times 2 weeks, or times 3 weeks, etc. Tamara, very similar. She makes the same initial deposit, $250. But she is depositing $150 per week, so that's 150 times W. Again, any number of weeks we would multiply. Here's our two expressions. Again, constant term, fixed initial deposit, and a weekly term, how much they're depositing per week. Write those as a sum. The account is going to get both of their deposits, right? So Megan is going to go to into the account, this amount of money. Tamara's amount of money is going to get deposited into the account as well. We want to add each of the groups. So if I've kind of not writing this regrouping step, but just looking at it, each of them makes $250 initial deposit. So we add those up. 250 and 250 makes $500 for the initial amount. And then $175 per week plus $150 per week, like terms, that would be a total of $325 per week for the two people. And so this expression, 500 plus 325W, would be the amount in the account after they've made their deposits for a certain number of weeks. Again, we can't add the 500 and the 325. One's fixed, one's variable. Those things can't be added up unless we knew how many precise weeks they've been putting money in for. So here's an example of slightly different profit and spending. So when someone has a business, they need to spend money so that they can make investments or buy materials or pay people wages, and then they're going to get money from selling their product or selling a service. So here we have Cindy. She's spending $125 on ingredients for muffins. She's going to make some muffins. She's spending $92.40 for ingredients for bagels. Then she'll sell them and make some money. How can we show her total profit after selling M muffins and B bagels? So over here in the picture, we see that a muffin is selling for $2.40 and a bagel is selling for $1.80. So thinking about them separately, muffins, right? She spent $125 to make muffins. So that's negative in the expression, negative representing spending money. But she's selling muffins at $2.40 each. So that would be 2.4 times M because it's per muffin. If it were 2 muffins, we'd multiply by 2. If it's 5 muffins, by 5, etc. So this expression would represent her profit just on muffins alone. How much income she's making minus how much she spent to make those muffins. What would it be for bagels? Well, starting with how much she's selling them for, 1.8, $1.80 times B, the number of bagels, and then again, the negative 92.4, which is what she spent on materials, ingredients for the bagels. This would be her profit on bagels alone. Well, overall, she's got this bakery, this cafe. We want to add those two ideas together for her total profit. that would be how much profit she gets from her muffins, 2.4M minus 125, plus the amount of profit she gets from her bagels, 1.8 for each bagel minus 92.4. Here we have some negative numbers. Those are from her investments, what she had to pay for the ingredients. So adding our like terms together, we get a little bit of a different answer. We get 2.4M because that depends upon how many muffins she sells, plus 1.8B. That depends on how many bagels she sells. They could be different, right? She might sell 10 muffins and 8 bagels. Well, we can't add these together directly. So again, these are not like terms. And we wouldn't be able to add 2.4M plus 1.8B. We just write them next to each other because they represent two kind of separate ideas. The only thing we can combine in this expression is her initial investment. So that would be negative $125 spending on muffins minus $92.4 spending on bagels for a grand total of negative $217.40 that she spent overall. This is our final expression. Amount of muffins that she's making, bagels that she's making, minus her overall cost. Finally, some more examples of simple, just straight algebraic adding. This means no context. Here's a problem. Half x plus 5 minus 2y. Add that to a quarter x minus 3y minus 9. What do you get? Number 2, 2.68d minus 321.76 plus negative 8.42e plus 176.90. What do you get? And finally, this expression, adding those two together, what do you get? So here again, we have various groups. We have three groups, three sets of terms. In the first example, we have some terms with x in them, some terms with y, some terms that don't have either, the constant terms. Half x plus a quarter x, what is that? 5, that would be grouped with negative 9, those are our constant terms. And negative 2y grouped with negative 3y, those would be our y terms. What do you get if you add those groups together? In number 2, we have a term with d in it, 2.68d, but if you look through this expression, there's no other term with d in it, so it's not going to be added. Negative 8.42e, that has an e in it, but again, there's no other term that has e in it, so can't really be combined. The constant terms, however, 176.90, can be combined with negative 321.76. So what would we get as a simplified form of that expression? I'll give you 1 minute to think about these three problems, maybe a couple minutes, and then I'll show you the answers for 1 and 2. The third one is for you to figure out on your own. All right, so we'll see how your thinking was going on these three problems. First problem, we have some fractional values of x, half plus a quarter. That'll make 3/4 of x, 3/4 times x. The 5 plus the -9, I have made an error in the video. It's not -5. What's 5 plus -9? -4. My bad. But -2y plus -3y does make -5y. And again, when we're done, we order them in alphabetical order. So the x would come first, y comes second, and the constant term last. And I'm sorry, it's -4, not -5. Second problem, we talked about how d is its own term, doesn't get combined with anything. The e term also doesn't get combined. The only two things that get combined are the last constant terms. So what do we get? Still 2.68d, still -8.42e, but those other two terms combine to be -194.86. The last expression is for you to figure out. It's a mystery. Let's see what you come up with. Thanks for watching Expressions and Equations 6, and we'll see you in class.